Good morning, all of you. My name is Shreya Paridar. In this video, we will cover internal first section B, similarity and dissimilarity in feedback. Question number 1. Briefly outline how to compute the dissimilarity between students' feedback profile described by nominal attributes, department or elective chosen, asymmetric binary attribute attended workshops, yes or no, C numeric attributes, example CGPA or attendance percent, the term frequency vectors, keywords in open text feedback. Answer of the question is for the nominal attributes like department or elective chosen. For example, when we compare two students, if they have same attribute, then the dissimilarity will be 0, and if they have different, then the dissimilarity will be 1. For multiple nominal attributes, we compute the simple matching dissimilarity, which is D is equals to number of mismatches upon total nominal attribute. To calculate the dissimilarity, our formula is number of mismatches upon total number of nominal attributes. Now in second part, B, asymmetric binary attribute. For attended workshop, we will represent yes, so 1. If no, so then 0. Only the presence 1 matter here, absence 0 is not informative. We will use Jacquard dissimilarity formula. The formula is to calculate the dissimilarity is D is equals to 1 minus A upon A plus B plus C. Here A, when both the student have 1, B and C, one has 1 and other has 0, and D we will ignore the both. Now, so that case we had not added D here because it will be 0. That's all. Now C numeric attribute for the CGPA or attendance percent. First we will normalize the value min max or Z score to remove scale difference to compute the distance. Usually equal division or Manhattan distance formula is used to calculate the distance. To normalize, we have generally two methods, mean max normalization and the Z score. After normalization, this distance itself represents the dissimilarity. Now D, the term frequency vector, the keyword in open text feedback, convert the feedback text into TF or TF-IDF vectors. To compute it, we require the cosine similarity, then convert to the dissimilarity. To calculate the similarity, our formula is 1 minus A dot B upon magnitude value of A and magnitude value of the B. This is our cosine vector formula, and when we have to calculate the dissimilarity, we will subtract it from 1. Now question number 2. In question 2, suppose two student-faculty interaction profiles are represented as tuple. Tuple 1 consists 22, 1, 42 and 10, and tuple 2 consists 20, 0, 36 and 8, where attribute represents the hours spent in monitoring, project review attended, assignment submitted, and infrastructure usage count. Now we have to compute the equilidivision distance, Manhattan distance, Minkowski, where h is 3, and the supremum distance. To calculate the equilidivision distance, our formula is under root x minus xi minus xj whole square means here xi1 minus xj1 whole square plus xi2 minus xj2 whole square plus so on up to n term. So first of all we will find the absolute difference of the given data as here 20 and 21. When we subtract both, the modulus value of both is 22 minus 20, the modulus value is 2. Similarly, with the 0 and the 1, our value is 1. With 42 and the 36, our value is 6. And with 10 and 8, our value is 2. Now substituting these values into our formula. So D, the distance is equals to under root x1 minus xi1 minus xj1 value is 2. Similarly, for 2, we put 1 square plus 6 square and 2 square. When we add all, so our distance is under root 45, which is equivalent to 6.70 at. Now the second we have to calculate the Manhattan distance. To calculate this, our formula is D is equals to summation of I is equals to 1 to n, the modulus value of xi minus xj. Now we had already calculated the modulus value, so we will substitute these modulus values into our formula to get the distance. So here n is equals to 4 as according to our question 1, 2, 3, 4. So our summation will be up to 4. So from 1 to 4. So D is equals to 2 plus 1 plus 6 plus 2, as this value we had taken from this absolute value we had already calculated. So our distance is 11. Now see the Minkowski distance where h is our 3. To calculate this distance, our formula is summation from I is equals to 1 to n, the modulus value of xi minus xj whole power h, then whole power of the modulus value summation is 1 by h. Now the distance is, here h is our 3, so this will become the cube root. So cube root, in summation we have to add the absolute values. So we had already calculated here absolute difference. So we will substitute this absolute difference, and here h is 3. So we will perform the cube of all the absolute difference. When we calculate this, we will get our distance 6.153. Now the supremum distance. To calculate the supremum distance, we have to find the max from our absolute values. So 2162 are our absolute values, which we already calculated here, which we had already calculated here. Now we will substitute and check which one is the max. So here 6 is max, so our distance is 6. Now the next question. The median score is often a key holistic indicator of faculty or infrastructure performance. When dealing with massive student feedback data sets, processed methods for median approximation analyze their complexity and suggest heuristic to balance the accuracy versus efficiency. The answer of the question is, when evaluating the faculty or infrastructure performance, the median feedback score is preferred because it is less affected by extreme high or low responses and represents the true central tendency of the student rating. However, in a large scale student feedback system, data sets may contain thousands of records, and computing an exact median repeatedly can be computationally expensive. So especially if data must be sorted, so it make easy for computation. So next, the to address these median approximation methods are proposed. These methods avoid full sorting and instead use efficient selection algorithms such as quick select, which reduce the complexity from big of n log n to big of n on average. Other heuristic includes, first, the sampling based approximation, selecting a small random sample to estimate the median. The next, histogram or the bean based grouping scores into frequency intervals to approximate the median range. Next is streaming median algorithms, using two priority heaps to maintain a running median in big of log n time per updates. The last one, this approach aims to trade the slight loss of accuracy for major gains in speed and memory efficiency, making them practical for real-time academic feedback analysis where performance monitoring must be timely and scalable. Number 4, considered student faculty similarity analysis, a sample data set of two attributes, faculty responsiveness and infrastructure support. The data is given, as you can see here. As you can see here, data is given. Here we have two attributes, faculty responsiveness and infrastructure support. And here S1, S2, S5 are our student. So the new feedback query given, which is our 1.4 and 1.6. Now in first part we have to calculate a rank existing students feedback profile by similarity using equal division distance, Manhattan distance, supremum distance and cosine similarity. In B part, we have to normalize each student's vector to unit length and compute using equilibrium distance. Solution. As you can see here, we will first compute the similarity and the ranking. We have 5 students and the 2 attributes given, that is faculty responsiveness and infrastructure support. Now the given query vector consists 1.4, 1.6. To calculate the equilibrium distance, our formula is under root x1 minus si1 whole square plus x2 minus si2 whole square. As we know that our x1 is 1.4 and x2 is 1.6 from the given query vector. Now we have to calculate the distance for student 1 when we substitute the attribute 1 and attribute 2 for student 1, which is 1.5, and 2, then our distance for S1 is 0.412. Similarly, we will calculate the distance for our remaining student. Then we will compare the distance of all the 5 students, which one is the minimum or smallest, so that distance will be most similar. So here our S4 is the smallest, so it will be most similar. So here first S4, then S3 is greater than S4, then S1 is greater than S3, then S5 is greater than S1, and S2 is greater than S5. Now to calculate the Manhattan distance, our formula is the summation of absolute value. So here our x1 is 1.4 and x2 is 1.6 from the given query vector. Now we have to calculate the distance for all the students. So we will substitute the attribute a1 and a2 for student s1, which is 1.5 and 1 and 2. So then when we perform the calculation, our distance for s1 is 0.5. Similarly, we will calculate the distance for the remaining student with the help of our given data set, as you can see here. Now to checking the rank for student 1 to student 5, so here the minimum, the smallest distance is for student S4, which is 0.3. S3 is greater than S4, then S1 is greater than S3, and S5 is greater than S1, and S2 is greater than our S5. Now calculating the supremum distance. To calculate the supremum distance, our formula is max of modulus value of x1 minus si1, comma modulus value of x2 minus si2. Now we are calculating the distance. So our max value here, x1 is 1.4 and x2 is 1.6 from the given query vector, and here we will substitute the attribute value of s1 for attribute a1 and attribute a2. For here we have 1.4 from, as you can see here, 1.5 and 2. 1.4 minus 1.5, we will get 0.1, and 1.6 get minus from 0.2, so our answer is 0.4. When we compare both the values, our max value is 0.4. Yes. So similarly, we will calculate the distance for other students from the given data set. Now we have to compare the rankings. So the smallest one is S4 and S3. Both of them have the similar distance. So this one is our smallest distance. Then S1, then S2, and S5, both of them have similar distance. Now calculating the cosine similarity. To calculate the cosine similarity, our formula is x dot si upon magnitude value of x and si. To calculate the distance, we have formula 1 minus cosine similarity. So first of all, we will calculate the magnitude value of x and the magnitude value for all the students. As we know that the query vector given 1.4, 1.6. With the help of query vector, we will calculate our magnitude value, that is 2.126. To calculate the magnitude value, simply we have to perform the square and substitute square of the given terms and into under root. Here 1.4 square plus 1.6 is square inside the under root, so we get our magnitude value of x is 2.126. Similarly, for student 1, student 2, student 3, student 4, and student 5. Here, this is our attribute 1 and attribute 2 for student 1. When we substitute and calculate, so our magnitude value for S1 is 2.5. Similarly, we will calculate for S1, S2, S3, S4 and S5. Now performing the dot product. As we know the value of x, which is 1.4 and 1.6 from our query vector, and S1 having 1.5 and 2. As attribute value for S1 is attribute 1 1.5 and attribute 2 2. We substitute and calculate, so our dot product is 5.3. Similarly, we will calculate our dot product for remaining all. Now calculating the cosine similarity. So to calculate the cosine similarity, as this is our formula, we will substitute value as we had calculated the values. Now we have to substitute these values into the formula. When we substitute these values, for example, we will see one S1. Our x is x dot si for first is 5.3. We substituted 5.3. Now the magnitude value of x is 2.126. We substituted here, and the magnitude value of si matlab s1 is 2.5. We product it with 2.5, so our value is 0.997 cosine similarity for S1. Similarly, we will calculate the cosine similarity for the other students. Now, the cosine distance ranking, the smallest distance is equals to most similar. To calculate the distance, we will subtract cosine similarity from 1. This is our cosine similarity, so we will subtract it from each of them from 1. When we subtract it from 1, so we get our distance this. Now we will compare this distance, which one of them is the smallest. So the smallest distance is S3 and S4, both of them are similar. After that, from S3 and S4, S1 is greater than S1 is S2 is greater than S1 and S5 is greater than S2. Now in B part, we have to normalize the equidivision distance. To normalize each student vector to the unit length, our formula is SI vector is equals to SI upon magnitude value of SI. So here x vector is equals to x upon magnitude value of x. So as we know, our query vector consists of 1.4 and 1.6, and the magnitude value as we had calculated here is 2.126. So we substituted here 2.126. Now 1.4 divided by 2.126, so our answer is 0.658. When we divide 1.6 upon 2.126, then our value is 0.753. Similarly, we will calculate it for the students also. So student has two attributes, which A1 1.5 and A2 2. Get divided by magnitude value of S1. So as magnitude value of S1 is 2.5. So we substitute here 2.5. When 1.5 get divided by 2.5, we will get 0.6, and when 2 get divided by 2.5, so we will get 0.8. Similarly, we will perform for S2, S3, S4, S5 vector. Now substituting them into our equidivision formula. So as our the query vector get normalized to 0.658 to 0.753. So our x1 and x2 value is 0.658 and 0.753. And here we will substitute the normalized student vector value. So for student S1, our value is 0.6 and 0.8. When we calculate this value, so our distance is under root 0.005. Similarly, we will perform for student S2, S3, S4 and S5 vector. When we check the rankings, so here our S3 is the smallest one, then S4 greater than S3, then S1 greater than S4, S2 greater than S1 and S5 greater than S2. Thank you.